So yeah, this is the problem we will try to solve. So we want to design a service in which people can find nearby friends. So let's say they have a Facebook or Instagram. On such app, they want an extra feature called uh, nearby friends, where they can go and search like who are nearby friends.
Okay, so it's an extra feature
Right.
on app like Facebook and Instagram
Right.
to find nearby friends. Okay, and this is a little broad. I wanna define some scope so that we can start, coming up with functional requirements. What do we
Sure.
mean by finding nearby friends? Um, do we have a rate?
Nearby geographically. Yeah.
So I'm assuming we have our
Sorry.
location, which is
Yes.
a center, right? The location of our device is a center. We're gonna have a radius.
Mhm.
We're gonna have a radius of some sort, and we can configure that radius, right? And
Right.
people who are our friends that are nearby within that radius are gonna be returned on some sort of a list, or like what's the experience gonna be like?
Right. Yeah. So it's the experience gonna be like, let's say that they open this app like My Nearby Friends, and in that tab on the map they will see smiley faces and the name of those friends, which they fall under that radius.
Mhm. And do we have a cap on how many friends? Like, let's say we're on a show, right? Taylor Swift concert. Like, do we care if you want to limit to 20, or maybe we want to paginate?
Hmm. Oh, that's a really good question. Yeah, maybe 2025.
Okay, yes, 20 to 25. Consider pagination. All right,
Mhm.
and our friends are going to be contacts, and I'm going to assume that they're already our friends, and that designing the part where we make friends is out of the scope.
Right.
Okay. All right. So we have find nearby friends. Okay. All right. So let's try and start defining the functional requirements here, right?
Mhm.
What will trigger this feature? Is it a button in the cell phone? Will I open the app? Is it going to be a widget? How will I interact? How would myself as a user interact with the feature?
Sorry.
If how would, like, if I were a user of this feature, how would I interact with it? Is it a button on the app? Is it a
Yeah,
tab?
there would be some button which, yeah, there is a button on our app which opens a new screen in which this response would be like this screen would be. Correct.
In the newsfeed as some sort of a widget, right?
New screen. I mean new screen. Yeah, new screen or widget. Okay.
Okay. It's important to know because if we show this as a widget on the newsfeed, we're gonna have a lot larger volume of reads than if it's a button and we have to
Hmm.
like go on a separate screen. So it's good information to know this, right? So
Right.
I'm feeling I'm feeling confident about this, and I feel like we may be ready for defining the functional requirements. Uh, so
Okay.
let me start with that. So the obvious feature is, as a user, I should be able to see a list of my nearby friends
Mm-hmm.
when I access the new feature, right? As a user, I need
Mm-hmm.
to share my location so that my friends can find me if I am within their radius.
Right.
As a user, I should be able. Okay, so all right, so I need your help with this one. Is this radius configurable?
Mm-hmm. Sorry.
Is this radius configurable? Can I say, hey, I want to, or
That's a yeah. We have like some fixed radius. Yeah, but not custom.
okay,
Let's say
so
like maybe 2, 5, or 7, something like that, but not a custom input.
between 2 to 3 kilometers, or like some fixed radius, right? Defining that radius will not be a trivial
Right.
problem, but the fact that the user
Yeah.
will not need, the user will not be able to configure that radius will cut one use case, right? One functional requirements that we would otherwise need to have. All right,
Okay.
so as a user, I should be able to see a list of my nearby friends when I access the new feature. And as a user, I need to share my location so that my friends can find me when they access the feature and I'm within their radius. And I think
Mm-hmm.
if we don't configure the radius, I think these functional requirements may satisfy what we want, what we expect for the new feature. Am I forgetting anything? Do you think this is good enough?
Mm. I think yeah, these are good enough.
Okay, awesome. All right. So I'm going to move on and I'm going to start defining the non-functional requirements. Now, these are important because um, from my experience, we should be able to use these to guide our decisions when we contemplate multiple design choices on the project. So, what are the crucial non-functional requirements here? Um, I think availability,
Mm-hmm.
scalability,
Okay.
performance, and I need to think about consistency because I don't know what kind of trade there's usually a trade-off between availability and consistency, and it's
Mm-hmm.
hard to just see what those trade-offs would entail in a system like this until I just
Okay.
started defining the components. So I'm going to put
Okay.
consistency here, and this is going to be like a bonus, right? If this is important in the
Mm-hmm.
end, we can reorder. But for now, I'm going to do it like this, right? So availability, we should have a service that's very available. It should obviously scale to Facebook and Instagram scale. Ideally, performance should be prioritized because it's always a good user experience to have a fast service. And in the end, if it may be the case where consistency will bubble up the ranks depending on how the system becomes. But for now, I'm going to put it on 4. All right.
Okay.
Uh, Usually here I contemplate a few different options, right? So we can, one, design the API, or two, try to
Mm-hmm.
estimate traffic or data requirements, or three, we can try to come up with data models, right? So do we care about should I try to design an API?
Mm-hmm. Yeah.
All right.
Before that, like, can you do some estimates like how much would be the QPS and how much would be storage requirements?
We can do those in any order, right? So I said the 3 things that I like to do
Okay.
before I jump into the high level architecture. So we can do estimation
Sure.
first. Um, and those are traffic and data storage estimations, right? Okay. Um, Now, I think we need some answers here before we move further, right? How many users? How many users does this
Good question. Yeah, let's say that 10 million daily active users.
10 million daily active users?
Yes.
Okay. And what's the average number of friends each user has? Is that a good metric?
Let's say that 1,000. Yeah, I think like that's an important question.
No, yeah, I'm just
Let's
wondering.
say 1,000 max. Yeah, 1,000 max. On average, let's say 500.
500 friends. Okay. So on so the 100th percentile of the number of friends is going to be some person having 1,000 friends, and on average we're going to have 500 friends per user, and there
Right.
are 10 daily active users on the platform. Okay,
Right.
sounds good. Uh, all right, so let me try and define what a record would look like, right? So I'm assuming that at some point we're going to be sharing our coordinates, latitude and longitude, and we're going to be storing that in some sort of data store, right? So uh, user location, that's going to be something like latitude, which is going to be a floating point, longitude, also floating point. And this thing is going to be an extra field on the user profile, right? So,
Right.
sorry, you
Yeah.
were saying?
Yeah, I think like these would be yeah, maybe along with that, maybe some meaningful name. But yeah, I'm not sure. We can come back to that. But I think for now, that long was enough.
Yeah, no, this is the draft, right? We can refine this later if we have the time for it.
Sure,
Uh,
sure. Yeah.
okay, so this is not a lot of space. This is not a lot of extra space, right? So what if we put this in terms of bytes of bits, right? And we consider that this is ASCII, so this is 8, 16, blah blah blah. I would say this would be something in the order of maybe 300 bytes, not 300 bytes, 100 bytes, maybe 800 bits or something like that.
Hmm.
And
Okay.
if we're gonna be adding this to every user profile, right? This is gonna be all right. Hold on. 200 bytes, right? So the extra storage that we're gonna need is something in the order of 200 bytes times 10 million daily active users. Do we care about non-active users though? Because if we're going to be adding these to
I think like for now, let's say that non-active users are not much. So yeah, we can ignore that.
okay, so um, if this is
So
a if
yeah,
this
so daily, what I mean by daily active users are at least these are the users who are sharing the location for this feature. Yeah.
oh I see um, okay, so all right, so this would be 2,000 megabytes,
Uh-huh.
which is 2 gigabytes, which is not too much. Which is great. If we need a lightweight data store for this, there's a chance where we don't have to shard it as much, which is nice. Um, all right. Can I assume that we already have a data store storing all the friends, like all the friend relationships, right? That I have.
Yes.
Okay, awesome. Okay, so this is probably good enough for data storage estimation. What's the frequency of requests that I should expect on a daily basis for an average user? How many?
To access the how many time he will check the nearby users, or
Yes, on average.
uh, yeah, we are expecting like at least 10 times.
To feature 10 times per day. Okay.
Yes.
And what is the expected delay on location, right? Because if we're gonna be doing something if we're gonna be doing something like this, I expect users to be sending some kind of a heartbeat request to one of our servers in the backend to share their
Right.
current location, right? So what is an acceptable delay for us to be able to pull that, right? So we can
Oh,
send
that's a
it.
really good question. That's a really good question. Yeah, let's say that 15 second is 30 second is acceptable.
Oh, acceptable delay for updating location. All right. Okay, so for traffic estimation, we can
Oh,
okay, so each one of our daily active users, of our 10 million daily active users, is expected to access the app on average 10 times, right? And I think this is a realistic estimation because there are people who are going to be accessing less, and obviously we're going to have some power users, and the average, I think, is going to be a good measure of how many total requests we should be expecting in terms of traffic for this new feature. So in terms of access, the access request, we're expecting 10 requests per day times 10 billion users, right? That's going to be 100 million yeah, 100 million requests per day. And we can convert this to seconds so that we can arrive at a neat QPS value. But do you think this is good enough? I'm just
okay.
worried about time.
Sure.
This is good. This good enough?
Yep.
Okay, awesome. And in terms of the location heartbeat request,
Can you just convert this into per second? Just like small thing from per day.
I see. All right. Hold on. So times 24 hours per day times 60 minutes per hour times 60 seconds per minute. This should give us something
Right.
per second. Now, I need to grab my calculator if we really want to convert this.
No, that's okay. You can roughly you can convert this into like into 100, like for simplicity you can assume 60 as 100 and the 60 also as 100 for safer thing, and this 24 as 10, it will be approx thing.
All right. Yeah. Okay. So if we want to make the math easier, this is going to be 10 to the second, 10 to the fourth, 10 to the fifth times. This is going to be 100 million. Million is 10 to the sixth. So this is like 10 to the eighth, right? If we multiply it by, it's going to be 10 to the eighth times 10 to the fifth, which is going to be equal.
Divided, right? It
Huh?
would be divided, right? These things go as in division.
Oh yeah, sorry. Hold
This
on.
would be division, right?
No, yeah. I got confused. um, so 10 to the third, 10 to the power of 3. So that's 1,000.
1,000. Yes.
Yes. For this query.
Right.
Okay. All right. So for the other request, right, the heartbeat request, this will be
Mm-hmm.
every user will make one request every 30 seconds.
Mm-hmm.
So in terms of QPS, we can consider as if one user makes 1/30th of the request in a second, right? If we're trying to
Good. Good way to look at it. Yeah.
QPS per user, that's times
Mm-hmm.
10 million users equals 10 million divided by 30. That's 1 million divided by 3, which is
Mm-hmm.
3,000, no,
300,000.
333,333 or something like
Yeah. Let's approximate to 300,000. Yeah.
QPS.
Right.
Yeah. So I think this is probably enough estimate because I think we're covering all
Yeah.
the use cases, right?
Right.
All right. Okay. So do we want to design an API for this?
Sure.
All right. So there is two functional requirements that we want to attend that we want to satisfy here. As a user, I should be able to
Mm-hmm.
see a list of nearby friends when I access this feature. That could be something like get nearby friends
Mm-hmm.
in my user ID. And since the radius is fixed, I'm not going to put it as an argument here, right? But if it was, we could put radius as a second argument. Um,
Mm-hmm.
if we were looking at the REST contract, this would be get slash friends slash nearby user ID equals my user ID. Or if we have authentication, this could be something like in the headers. I have a session token or a user token with which the backend services could parse them and somehow use them to retrieve the user ID associated with my application, right? With my session.
Mm-hmm. Mm-hmm.
So this should be a good start for the first use case. The second use case is update user location.
So, won't you need like user's current location with this API, or like you are assuming that it would be stored somewhere on the server?
Good question. Because if I'm sharing my location, in theory, I could get this from a backend data store. But if we
Okay.
really want to, we can share the location here as well.
Okay.
Something like this, right?
Right.
And update user location, latitude, longitude, and that's it, right? it doesn't return anything. Just returns maybe a 201, no content or like acknowledgement. In terms of if we were to design this as a RESTful service, this could be a patch, right? Or a post. It really depends. So patch slash user slash location. And I don't know if we want to be putting it on the query string just for security purposes, because if this is sensitive information, user location sensitive information, it's PII, I think, right? So obviously we're gonna have a session token or a user token or something that our backend services can use to identify who's making this request. And then I think I'm gonna put it on the body, right? So that over HTTPS, everything's gonna be encrypted. It's gonna be less easy for like a malicious middleman to just take a look at the location of the user at regular intervals, right? So latitude, longitude. And I think this is, what do you think about this API design? Do you think this is good, or am I missing something?
I think, this is good. Yeah, maybe you already know the header. So like from user token, user, and providing that now.
Sorry, I think you broke up. I'm trying to understand your last message. Is this good? Do you think I'm missing?
Yeah, I'm saying like this is enough.
This is good enough, right? Okay.
Yeah.
All right. So I think we should probably have enough to start drafting a nice high-level architecture for the service. I'm just thinking about what kind of a data store. I'm just thinking what kind of a data store would be best suited for us to be able to store these locations, or if we should be storing them on the user profile data store along with the rest of their profile. Just because this data is ephemeral, and I think it's gonna be changing often. So I'm not sure. Maybe a key value data store would be a good idea. Something that resembles a cache, like a Redis data store. And if it is something like a cache, we could set a how do you call it, a retention policy, right? We could set a TTL so that users that are no longer active or that logged out for more than like 15 minutes, they're just going to be overwritten. The more I speak, the more I'm convinced that this should probably be a good way to do it. Yeah, so I'm gonna go to the whiteboard, I think.
Yeah, so I move to the whiteboard.
Okay. All right. So yeah, let's start with the user, right? Okay, I'm gonna do squares because I don't know how to scala draw.
No problem.
Okay, so I have the user, right? And I'm gonna do the diagram for sharing my location first. So I'm gonna define something of an API gateway. It's a very common component. It's a very common front-facing back component for backend applications today. And the API gateway is great because it has some responsibilities which are very neat. We would expect we would expect it to be the component that performs the authentication and the authorization, meaning it extracts the tokens out of the headers and maybe parses them if they're JWTs or if they're just opaque strings. It would just try to fetch the user information out of some data store and you get the user information inside the request, and then attach it as some header to our internal backend data structure. Load chatting, rate limiting, all that good stuff. It's going to be here, right? It's going to be on API Gateway.
Oh.
And okay, so how do we do this? So here's my key value cache, right? And key value cache is going to be, how do I, okay, stores. So the key is going to be the user ID.
Okay.
And the value could be the pair of longitude and latitude, right? Yeah. And we could define the service that will be the logical cache manager as we could call it the user location service or the user location manager. Right, and it would be as simple as this, right? So every 30 seconds or so, we're gonna make that request, that batch request, to get my location into the key value data store, passing through the API gateway. And this guy will populate the key value data store. Right? So this is
okay. And how this key value data store would be like? What would key is your user ID and the value is like long. Okay. How will this be optimized for querying part, like, because the query is like how? Yeah, let's talk about that part and then like come back to this.
Sorry, can you repeat? It's hard for me to understand you.
So yeah, I understood the writing part of it, the way you are writing data into the key value store. But yeah, let's also talk about like how you would query the data from this key value store.
I see. So we're talking about the other flow, right? We're talking about getting the list of nearby users. Okay, so
yes,
I'm gonna define another diagram and pretend that this is the same user. It's just I'm doing this for ease of visualization. So here's the same user, right? And so I'm gonna make that request, right? Get list of nearby friends. And we're probably gonna go to another service. I think does it justify this being a different component? So this service is supposed to, given my user ID, get a list of my friends, and given that given that list of friends, I should get the key value the key values sorry. All right. So given that list of friends, for each friend I should get the location, right, the latitude and the longitude for that friend. And then, if it somehow falls under the radius, we put that friend on the list, or something like that. So I'm gonna do. How should we call this service? There's a case to be made for this functionality to be inside the user location manager itself, where semantically it's location management, right? Like getting a list of the nearby friends is something that user location manager could be responsible for. the reason why I don't like this is because um, if we separate these services, we should be able to scale writes and reads separately, right? We're obviously going to be doing a lot more writes, and there's
Right.
probably a lot of need for us to scale reads alongside that. So I'm going to call this um, nearby friend service, right? So the user's gonna make that GET request. That GET request is going to be redirected by the API gateway into nearby friend service. Nearby friend services, nearby friend service then will make a call to this black box that I'm going to define, and I'm going to call it the friend services, right? So
Okay. So this service exposes your API, the first API which you wrote in API design, right?
yes,
Nearby friends service.
yes,
Okay.
and we're gonna call this service, and we have agreed that this functionality is already built, so it's out of the scope for this design exercise. And
Sure.
I'm gonna give it my user ID, and it's gonna give me a list of friends for that user ID. All right, and okay, so now I have a list of my friends, right? And I know that those friends are limited to 1,000 friends. A naive approach here would be for me to, then query the cache, right? I can query direct. I think I can query directly, 1,000 times.
Okay.
This would be naive approach, right? Get the location for each of my friends, and then do some filtering based on location, and return the list of friends to my user. Because the number of friends is 1,000, right? It's capped at 1,000. I'm not entirely sure whether Redis is capable of doing bulk requests, right? Because if we could batch this somehow, it would be great, because we would offload a lot of network
That's
IO
a good point.
out of this equation. I don't know if Redis supports that, and I think
Let's assume that it supports. Let's assume that it supports. Yeah.
Okay.
Or maybe you can, worst case, you can have like something on top of Redis, which does this for you and return back to you. So on network, you're talking in terms of
I got toggled back to the text editor. I don't know what happened. Okay.
You can click on bottom left, toggle whiteboard.
Oh, no, yeah. Okay. So, all right. So, all right. Let's pretend that Redis supports batching, right? So we can batch request for location of my friends. And then, if
is there any efficient way of representing the data to facilitate the query part?
The query part. Well, what data are you referring to? The user profiles or the location?
The location.
The location. I have heard about an algorithm. I have heard about a hashing method called geohashing, which seems to be very useful for us to represent location.
Okay.
I have seen instances.
Do you have an idea about it?
Sorry.
Do you know how it works?
Yes, it's a hashing method that produces a string based on um, how do I say this? It produces a string based on the location, and that string gets longer as the location gets more precise. So like if we're looking at like a
Okay.
huge chunk of Earth, then the number could be
Mm-hmm.
9, right? And if we're looking at like 1/8 of that huge chunk of space, then it would be like 9e or
Mm-hmm.
9 or something like that. And as we get smaller and smaller, that string gets longer and longer. And I think it can go up to
Right.
19 characters of length, and that's like pretty impressive. It's like nanometers of precision. Um,
Mm-hmm.
so I think there's a case to be made here where we could perhaps um, use this geohashing to efficiently store the latitude and longitude encoded as the geohash string, right? So it'd be something like 9EVGF38,
Mm-hmm. Mm-hmm.
something like this, right? And then when these results return from the batch call, it's going to be it's going to be a lot easier, I think, to compute the users that are closer to me, just because
Mm,
this
but
this
you will still need to do but you will still need to do the 100, like if there are whatever number of users that may require queries, right?
Can you repeat that last part? I just want to make sure I understand.
So you will still need, when we are batching, right? You still need to identify like the location of those many friends or those many users, right?
Well, yeah, it could be it could it could be that
So
we
what
we
would be key now, and what would be the value?
hmm, I don't know if I don't know if geohashing is expensive, right? That's
Okay.
one of the things that I don't know. If it's
Mm-hmm.
a cheap operation, it could be the case that we can keep the
Um,
cache and we can hash it
mhm.
here.
So rather than like, let's say that you don't know about your hash, like what would be the more efficient, like generic, simplified, any simplified solution which comes to your mind?
Hmm.
You don't know about the geohash part.
Yeah, the geohashing is a technique I recently read about. I'm not
Mm-hmm.
I'm not by all means entirely uh, an expert by any means. Let's see. So geohashing takes a longitude and a latitude and returns me a string. And if I compare two strings from geohashing, they the common prefix tells me something about their distance.
Mm-hmm. I think, yeah, that's okay. We already like hit like 45-minute mark, so let's pause for feedback.
Okay. Yeah. Please be brutal.
I think, yeah. So I think, yeah, you did well in clarifying the definition of nearby, right? So which was important. I really like the way you were more worried about like user experience. So you clarified like how many number of friends to be displayed. You talked about pagination. So yeah, those are really good things when you are talking about product design interview, because like in product design, user experience is more important as opposed
Yeah.
to other, right?
Hmm.
So yeah, I think like those were a really good point. Then you talked about assumption that uh, creating a friend or making friends is out of scope, and you clarified users would interact with like how the feature would be used by the user. You also clarified the ability to be provided to user by mentioning that user would be able to share their location, user will be able to see the list of nearby friends. So yeah, so I really like attention to details there. I think like though it was good attention to details, I think like these things were too like too obvious, and like writing them down did consume some time, which could have been saved for later in a discussion, right?
Yeah. Hmm.
Then yeah, so I think like you clarified whether the radius is custom or not, which was a good point. You identified that availability, scalability, and performance are important, and you also identified the trade-off between consistency and availability. Um, yeah, and you clarified like how many users would be there. You also clarified how many friends the user can have. You use these numbers to identify the QPS and storage, right? So you also clarified. I really like the part that you clarified like how much delay is acceptable in terms of real-time location of a user, which was like important in terms of your calculations and designing the system.
Hmm.
So yeah, I think like you analyze the storage and the QPS correctly. I think like you should like you move to the API. You took a pause and asked like if you should move to the API design. Your API design was crisp, like has good abstraction on it. I think like you came up with like good like high level observation that read and write scale would be different. So you segregated the read and write part into two different services, exposing to different endpoints. So I like that way, like it's command query segregation. You also came up with like efficient way of represent, like you. I think like only thing is like you could have come up with like efficient way of representing data, which made a query part expensive, right? So currently it's very expensive to get all friends and then getting their location and then applying filter on top of it, right?
Yeah. Yeah. No,
Even though like you have things in mind, yeah.
I know there's a way
One
to
day,
do
one day, like,
that, but
hmm,
I couldn't figure it out. I read it recently. So I was trying to understand how it
yeah.
works.
A simple way would be like you can divide your location, like your region into grid, right? And you lat long bumps to a grid. Then you identify the people in that grid and just have interaction with the list of friends, and those will
Mm-hmm.
be your nearby friends.
Mm-hmm. Mm-hmm.
So
Yeah.
yeah, geohash is like one of the way to do it, but like simple way, like let's say for example, if you're working in a country for for sake of discussion, 100 cross 100, you will have like 1 cross 1 grids, and then you nearby the people in you query the people in nearby grids, you query the friends, take intersection, and yeah, and then apply the filter of distance, and then share the results. So it would be less number of queries as compared to this.
I see. Yeah. No, it's good feedback. Thank you. Thank you very much.
Yeah, but I think like yeah, I think I know that this is the you haven't seen these kind of problems, but yeah, you can expect these kind of problems. So I what I can recommend is to look at a problem called Uber booking, which has a similar application of identifying the nearby drivers and things.
Yeah.
So you get a hang of like how such what the problems are and how you can solve it. So yeah, maybe you can search some video on Uber design or some blog post on Uber booking.
Mm-hmm. I see. Good. Yeah. So do you think I'm taking too much time, or is there anywhere where I can go faster, or
I do think like in functional requirement there was a scope to go faster. I think this problem was indeed had a lot of things while doing the estimation, and it's a good thing that you covered almost all of that. Those are really good signals. But yeah, in just like as I pointed out, like rather than writing out the obvious things like users should be able to see and those things, and
Mhm.
writing them down, those things could have been skipped.
Okay. Okay. Sounds good. Um,
Yeah, but yeah, I do feel like you should not cut down anything from non-functional requirement. Those are important, and I think like for this problem, your questions regarding daily active users and other things were important while designing it. So yeah,
Sounds good. Yeah. So is this a mock pass, or
sorry.
would this be a successful interview in your opinion?
Yeah, Yes, it would have been a successful interview. Yeah.
Okay, awesome. Thank you very much. Yeah, I don't get a chance to get feedback on on these kind of problems often. So I've been pretty much studying on my own, hoping for the best. It's really good to hear from someone who understands how these how feedback
Right.
goes. To really
But yeah, my suggestion would be like still look at like this Uber cab booking system design so that like you get a hang of those specific kind of a problems where location wise storing of data is important. So yeah.
mhm. Yeah, no, I'll take a look at it. Yeah, thanks
So
thanks for the hint. Is there going to be
yeah, so one another thing like which I usually suggest to people, like few things like which I suggest to people who are giving meta interview is like coding interview does not have any say on your leveling part. So while if an interviewer is writing a feedback for coding interview, he just say yes or no. He does not have any say on like which level you should be hired on. So
Mhm,
focus on getting two problems done in coding interview. So speed is a game in coding interview. You don't need to prepare for dynamic programming as Meta does not ask questions on dynamic programming,
mhm,
right? And for behavioral, if you are applying for E5 plus, do have a couple of projects which lasted longer than 1 quarter, longer than 3 months, because I have seen like people having bias that if you have all your examples are of smaller initiatives, they may think that you might not be able to handle complex, big enough project individually. So yeah,
mhm,
so have some examples which were long running. As your recruiter might have already told, do talk about numbers in terms of impact, like what was the final impact of your uh, interview and what was the final impact of your project and all.
mhm. Okay, yeah, no, I need to. How much time do you think I should save to prepare for behavioral round? Just because I've been focusing a lot on the coding and the design so far.
At least 2 hours. Yeah, write it off. 1.5 hour to 2 hours. Write it
Mhm,
off with these examples.
I
So
see.
yeah.
Sounds good. Sounds good. Well, yeah. It I really appreciate it. It means a lot. This feedback. Thanks for this round.
Anytime. Yeah. All the best for your actual interview. Yeah.